See, a group of small worlds far beyond Neptune are doing something they should not be doing. They lean the same way. They swing closest to the sun, in roughly the same sector of the sky. Nothing visible out there is holding them in that pattern. That is the whole case for a ninth planet, and it is also the whole problem with it. The evidence is not a photograph. It is a shape in a scatter of orbits, and shapes in small samples can be honest, or they can be an artifact of how we looked. Start with the distances, because the distances are what make this hard to settle. The objects at the center of this argument are called extreme trans-Neptunian objects. They orbit the Sun beyond Neptune at average distances of more than 250 astronomical units. One astronomical unit is the distance from the Earth to the Sun. So these bodies sit, on average, more than 250 times farther out than we do. At that range, sunlight is faint, the objects are small, and their motion across the sky is glacial. That is the observed fact, and it is worth stating precisely, because precision is the only thing keeping this story honest. The clustering has two parts. First, these extreme objects tend to make their closest approaches to the Sun in one sector rather than scattered evenly around the Sun. Second, their orbital planes are tilted in a similar direction. Two independent alignments in the same population is more interesting than one, which is why the pattern drew attention in the first place. Now, the expectation. In a solar system with no large unseen shepherd out there, the orbits of distant objects should not agree with each other. Encounters with the giant planets and billions of years of slow gravitational stirring should have smeared the directions of their closest approaches around the Sun and randomized their tilts. Alignment is the thing that needs explaining. The Planet 9 hypothesis explains it with gravity, an undiscovered planet in the outer solar system whose gravitational effects herd these orbits into a preferred orientation and hold them there. That is a hypothesis, not a discovery, and the distinction is the entire episode. No confirmed observation of such a planet has been reported. The proposal is an inference from the orbits of other bodies, in the same way you might infer a hand from the way a set of iron filings arrange themselves. It is a legitimate inference. It is also the kind of inference that lives or dies on whether the pattern in the filings is real. Here is how anyone knows the pattern at all. You do not measure a 250 astronomical unit orbit in one night. You find a faint moving point of light. You measure its position against background stars. You come back, you measure again, and you keep measuring across months and years until the arc of motion you have recorded constrains a full orbit. From that arc, you derive where the object comes closest to the Sun and how steeply its path is tilted. Every claim about clustering is built out of those repeated positional measurements, stacked into orbital solutions, one distant object at a time. And that method has a built-in weakness that the critics have put their finger on. Some astronomers reject the shepherding conclusion and argue that the clustering comes from observational bias, the practical difficulty of discovering and tracking these objects through much of the year. Think about what that means physically. A survey points at a particular patch of sky, in particular seasons, under particular conditions. Faint, distant objects are easiest to catch when they happen to be near their closest approach to the Sun, because that is when they are brightest. If the sky you searched was not searched evenly, you will preferentially find objects whose orbits bring them close to the Sun in the directions you happen to be looking. The clustering would then be a portrait of the survey, not of the solar system. So rank the explanations by what the evidence actually supports. The two live contenders are a real gravitational shepherd and a selection effect in a small, hard-won sample. Neither has been eliminated by the observations described here. A mixed outcome is also possible. Part of the alignment genuine, part of it amplified by where and when we searched. Nothing in the supplied evidence lets me hand you a winner, and I am not going to manufacture one. What I can tell you is why the disagreement persists. And it is not because anyone is being stubborn. It is because both explanations predict the same handful of aligned orbits. The best current statement of the situation is therefore narrower than the headlines around it. The alignments among the extreme trans-Neptunian objects are the observation. The undiscovered planet is one interpretation of that observation, and it is described as a hypothetical body, not a detected one. The observational bias account is a serious competing interpretation held by some astronomers. Confidence in Planet 9 is confidence in a pattern surviving scrutiny, and that is a different kind of confidence than seeing a disk of reflected sunlight in an image. What would settle it? The decisive test is not cleverer modeling of the objects we already have. It is a larger catalog of extreme trans-Neptunian objects discovered under search conditions that cover the sky evenly, so that the discovery process no longer favors one direction. If the alignments hold in a sample collected without that seasonal and directional handicap, the bias explanation weakens sharply, and the case for a shepherding mass gets much harder to dismiss. If the new objects fill in the empty sectors and the tilts scatter, the pattern dissolves and the planet is no longer needed. A direct detection of the planet itself would end the argument outright, and the absence of one so far is a real constraint, not a footnote. There is a reason the outer solar system keeps forcing this kind of reckoning. Pluto was found out there, in the Kuiper belt, the ring of bodies beyond Neptune's orbit. It is the largest known trans-Neptunian object by volume, though only by a small margin, and it is less massive than Eris. It carries roughly 1/6 the mass of the Moon, and about 1/3 of its volume, built mainly of ice and rock, far smaller than the inner planets. It was originally considered a planet. Its status changed when astronomers adopted a new definition of the word, with new criteria. The object did not change. The category did. Hold those two things side by side. The 9th slot in the solar system was once occupied by a body we could see and measure, and it was removed by a definition. The 9th slot is now claimed by a body we cannot see at all, argued for by the way other orbits lean. That is not a failure of astronomy. It is what the edge of a planetary system looks like when you study it with instruments that can barely reach it. So the honest answer to the strange orbit of Planet 9 is that the strangeness is measured, and the planet is not. The alignments of the extreme trans-Neptunian objects are on the record, in two forms: direction of closest approach and orbital tilt. The shepherd is an explanation competing against the possibility that we are reading our own search pattern back to ourselves. Both of those futures are decided by the same thing: more distant objects, found more evenly, tracked long enough to pin their orbits down. Until that catalog exists, the 9th planet stays where it has always been, in the mathematics of other people's orbits.